Hi, welcome back to my YouTube channel. Today my video is about the subject of CO and ARM. ARM stands for Advanced RISC Machines. So in this video we'll learn about embedded system hardware and embedded system software and also the topic of RISC design philosophy. Now let's move on to the introduction to embedded system. Embedded systems are specialized computing systems designed to perform specific tasks within a larger system. These systems consist of both hardware and software components that work together seamlessly to achieve their intended function. Embedded systems are found in a wide range of devices from consumer electronics to industrial machinery. Now let's see the embedded system hardware components. The hardware components of an embedded system typically include a microcontroller or microprocessor as the central processing unit. Other essential hardware elements may include memory. In that memory we'll get RAM and ROM, input or output interfaces, and power management units. The choice of hardware component is critical in determining the performance, power consumption, and cost of the embedded system. As we see in the figure, in embedded system, there are many hardware components like power supply and also the oscillator circuit, processor, input devices, timers, interrupt controller, parallel ports, serial communication ports, output interfacing. So like this, we have so many hardware components for the embedded system. Let's see the difference between the microcontrollers versus microprocessor. Microcontrollers are integrated circuits that contain a microprocessor, core, memory, and peripherals on a single chip, making them suitable for embedded applications. Microprocessor, on the other hand, required additional external components such as memory and input-output interfaces to function as a complete system. The decision to use microcontroller or microprocessor depends on the specific requirements of the embedded system, such as cost, power consumption, and processing power. Let's see now the embedded system software. Embedded system software is a set of programs and routines that control the operation of the hardware components and enable the system to perform its intended task. This software is typically designed to be lightweight, efficient, and real-time capable to meet the constraints of embedded applications. Embedded system software includes the operating system, device drivers, application software, and firmware that interact with the hardware components. Embedded systems are having many layers like application, system interface, RTOS, hardware interface, and hardware. Now let's see what's the RTOS. RTOS stands for Real-Time Operating System. Real-time operating systems are designed to manage tasks with specific time requirements in embedded system. RTOS provides features such as task scheduling, inter-process communication, and resource management to ensure timely and predictable execution of tasks. Choosing the right RTOS is crucial in embedded system development to meet real-time constraints and optimize system performance. Now let's move on to the second topic of this video is RISC design philosophy. Now let's move on to the introduction to RISC design philosophy. RISC stands for Reduced Instruction Set Computer. RISC processors use a simplified instruction set to improve performance. The philosophy focuses on executing simple instructions quickly. The RISC is used in embedded systems because of to improve the system performance. Even the simple instruction or simple performance is not to be done, RISC can be used. Key principles of RISC design. Emphasis on a small number of simple instructions. Emphasis on a small number of simple instructions. In this RISC design, even the simple instructions are also been given the importance and also given the value to perform very quickly and quickly of simple instructions. Single clock cycle execution for most instruction. In RISC design, if any one data has to be performed, the RISC design it is like this the performance it should be done in the one cycle itself, in one given cycle. Use of pipelining to increase throughput. We use pipeline in the RISC design because of overlapping when the multiple inputs are given to the computer to the performance. In the RISC design, we use pipeline to avoid the overlapping of multiple functions in the computer. Let's see advantages of RISC design. Improved performance due to simpler instruction and faster execution, easier to optimize and design efficient compilers, reduced power consumption compared to RISC architectures. In RISC, it is even simple instructions can be executed fast, and also it is efficient to compile and also to debug any errors are there, easier to optimize, reduced power consumption compared to RISC architectures. Evolution of RISC design. RISC architecture continue to evolve with features like out-of-order execution. RISC-V, an open-source RISC architecture, is gaining popularity. RISC principles are also influencing the design of modern processors. In this figure, we can see RISC architecture. In RISC architecture, we have main memory, data cache, data path, and also the hardware control unit and instruction cache. As we can learn by seeing the diagram of RISC architecture, the data is fetched from the main memory and it is sent to the data cache, and it is fetched through a data path to hardware control unit, where data path acts like a channel between the data cache and hardware control unit. The data which is fetched from the main memory is processed in the hardware control unit. We also have instruction cache where the data need to be processed, like perform any operation like subtraction, addition, any whatever. The instruction is given to hardware control unit to process the data. This is how the RISC architecture works. In this video, we have learned about embedded hardware system and embedded software, and also we have seen the RISC design philosophy. Thank you for watching.